that each of the probabilities of each outcome are 1/3. Oh, now let's move on to continuous random variables.
2.
Now, a continuous random variable takes all values of some interval of numbers. This means that opposed to the coins from before, we cannot place probabilities on the outcome of the results. To help better understand this, think of your common game spinner. You set the spinner from 0 to 1 to choose a value between 0 and 1. We do not know all the possible outcomes that the spinner can give us, so it is a continuous random variable. In addition, all continuous probability distributions assign the probability of 0 to every individual outcome around the spinner. The best way to graph a continuous random variable is by use of the density curve. We can graph the spinner on this density curve because it has all the values from 0 all the way up to 1, just like the spinner. So let's have an example. Say you wanted to find the probability of the spinner landing between 0.2 and 0.5. To show this problem, on the density curve we would locate 0.2 and 0.5. Then we would shade all the area residing in between these two numbers. This area represents 0.3, which is the answer between 0.2 and 0.5. Another way of finding this value is by taking the difference of 0.2 from 0.5, which will give us 0.3. Overall, in section 7.1, we've gone over random variables, discrete random variables, continuous random variables, probability histograms, and density curves. See you later.
Hi, I'm Scott. In this section, 7.2, we will learn about the mean of random and discrete random variables, as well as their variances. The mean of a set of observations is their average. Also, the mean of a random variable is an average of all possible values of x. Here is an example problem for a mean of a discrete random variable. Here we have digits of x, 1 through 5, that are equally random when chosen. The probability of any of the 5 is 1/5. The mean of x is 15 times 1/5. You can write it out like this or like this. This is just a simplified version of this. You just add the units of x, which are 1, 2, 3, 4, and 5, which gets you 15. Then you multiply that by the probability and you get the answer. Wow, wasn't that easy?